Recently, Nobel Prize winner Adam Riss said that we might have completely misunderstood the universe. And he's not the only one saying this. After the newest findings from the James Webb Space Telescope, many top scientists now believe the universe is much stranger than we imagined. First, we discovered Zhulong, the biggest Milky Way-like galaxy ever found, which formed far too early in the universe's timeline. That alone challenged everything we thought we knew about how galaxies grow. But now, the James Webb Space Telescope has revealed something even more alarming. This new discovery isn't just surprising, it's deeply troubling for astronomy. Astronomers recently found a giant barred spiral galaxy called J0107a, which dates back 11.1 billion years, only about 1/5 of the universe's current age. Using the ALMA Observatory along with NASA's James Webb Space Telescope, scientists learned that J0107a has a clear spiral shape and a central bar, similar to the Milky Way. But it's more than 10 times bigger and is forming stars at a shocking rate, 300 times faster than our galaxy. What makes this truly mind-blowing is that J0107a is already well organized during a time when most galaxies were still messy and unstable. Even more surprising, unlike modern galaxies with such extreme star formation, J0107a shows no signs of collisions or mergers. Its calm and isolated formation during such a chaotic era goes against everything we currently believe about how galaxies grow. But wait, there's more. What the James Webb Space Telescope recently captured in its deepest view of the universe so far is now sparking heated debate among scientists. This observation, which took over 120 hours, is the longest amount of time Webb has ever spent looking at one single spot. The final image reveals swirling arcs of light, showing galaxies that formed during the cosmic dawn, when the universe was only a few million years old. And from this image, scientists notice something important. The deeper we look into the early universe, the more strange and surprising things we continue to find. Scientists once thought Webb would simply show us how the early universe looked, how galaxies formed after the Big Bang, and how small ones slowly grew bigger over time. But what Webb has now revealed from the universe's earliest moments has caused an uproar in astronomy. More and more researchers are starting to say that it feels like we're seeing a completely different universe, one filled with huge galaxies and mysterious structures that don't match what our current theories predict. So, what exactly did Webb capture in this new observation? And why are some scientists now saying Webb might be looking at a totally different kind of universe? Back in 2016, NASA's Hubble Space Telescope made a major discovery. It spotted a galaxy named GNZ11, which at that time became the most distant and oldest galaxy ever seen. The light from this galaxy traveled 13.4 billion years to reach Earth, meaning we were seeing it as it looked only 400 million years after the Big Bang, when the universe was just 3% of its present age. But that wasn't the only strange thing. GNZ11 turned out to be unusually bright, large, and forming stars very actively, even though it existed incredibly early in the universe's timeline. This confused scientists because, according to standard cosmology, a galaxy that big and developed shouldn't have existed so soon. Still, many researchers believed GNZ11 might just be a rare outlier. That's because most of the other galaxies Hubble observed at similar distances, up to a redshift of 10, matched our predictions perfectly. So at the time, there wasn't much reason to question our current models. However, everything changed in 2022 when the James Webb Space Telescope began its science mission. Built to see deeper into space and further back in time than any telescope before it, Webb almost immediately started revealing one surprise after another. In its very first deep field image, Webb spotted several galaxies that set new records for distance and age. One of these, called Jade's GSZ140, was found to exist only 350 million years after the Big Bang, earlier than GNZ11. This discovery shocked astronomers. If GNZ11 wasn't a rare case, and other galaxies just like it, bright, massive, and very early, were appearing, it meant something might be seriously off in our current ideas about how galaxies form and grow. As Webb continued scanning the universe, the mysteries only grew. It started detecting even more distant and strange objects. Even more worrying, some of these objects are so bright and so large that scientists aren't even sure what they are. Are they galaxies? Supermassive black holes? Something completely different? Whatever they may be, they don't fit into any of our existing theories. These objects seem to have formed as early as 300 million years after the Big Bang, or even earlier. The biggest issue is that our standard cosmology doesn't predict this at all. According to current models, there simply shouldn't have been enough time for so many huge, bright structures to develop. Until recently, the most distant and oldest known galaxy was Jade's gst 140, which existed about 290 million years after the Big Bang. This galaxy still confuses scientists because its massive size at such an early point in cosmic history breaks what we thought we knew about galaxy formation. But just when researchers thought the surprises were slowing down, Webb spotted something even more baffling. An object called MOM-Z14, dating back to only 280 million years after the Big Bang. MOM-Z14 has a redshift of 14.44, which beats the previous record holder, Jade's gst 140, with its redshift of 14.32, an age of 290 million years. This discovery completely contradicts our current understanding of the early universe. Scientists still aren't sure exactly what MOM-Z14 is. A galaxy? A black hole? Something else entirely? Whatever it turns out to be, it should not exist this early according to today's theories. And the search for early massive galaxies doesn't stop at a redshift of 15. Researchers have found many possible galaxies between redshifts 15 and 30. Some have multiple redshift readings that still need more spectroscopic testing, but several remain strong candidates for redshifts higher than 15. And in a new study, scientists suggested that if even a small portion of these candidates truly sit at redshifts higher than 15, it would create serious conflict with our current theoretical models. With each new discovery, researchers are finding galaxies that are not only much more massive, but also far more organized than the Milky Way, appearing just a few million years after the Big Bang. The sudden appearance of these bright, well-shaped galaxies so early in the universe is raising major questions. Their existence suggests that the cosmos may hold far more surprises than we expected, especially as we continue to look deeper into its earliest moments. Many scientists now say that our standard cosmological models work well up to a redshift of about 10. But as soon as we look beyond that, into the very first stages of the universe, things start to look completely different from what our models predicted. So far, no current theory can fully explain what we're seeing in those first few million years after the Big Bang. And it's not just about galaxies forming earlier than expected. Scientists have also noticed that the expansion of the universe isn't happening at a steady rate. This suggests that dark energy, the mysterious force believed to drive the universe's expansion, may actually be changing and getting weaker over time. This challenges one of the main assumptions of the standard cosmological model, which says that dark energy stays constant. In fact, it even goes against one of Einstein's key ideas, that the expansion rate, also known as the cosmological constant, never changes. All these new discoveries point to something huge. We might be missing an important piece of the puzzle when it comes to how the universe truly works. Or maybe something very strange happened in the early universe, something we don't yet understand.
Our current theories have no explanation for it, and when we look as far back as we can with today's telescopes, up to just a few 100 million years after the Big Bang, we find something shocking. One of the very first galaxies already contains a supermassive black hole at its center. This only adds to the mystery of how such objects formed so quickly, because there simply wasn't much time between the Big Bang and the appearance of these early galaxies with giant black holes inside them.
Until now, by studying the nearby universe and tracing it all the way back to the cosmic microwave background, found at a redshift of around z=1100, scientists concluded that the universe began as a hot, extremely dense point known as the Big Bang. But the surprising findings from the James Webb Space Telescope are now forcing researchers to rethink that idea. The unexpected presence of massive, well-organized galaxies only a few 100 million years after the Big Bang doesn't fit smoothly with the standard cosmological model. Because of all this, some scientists are now looking into new ideas that go beyond the traditional Big Bang theory. One of these ideas suggests that other universes may have existed before ours, and that they might have even interacted with our universe during its earliest moments. Some speculative models even propose parallel universes filled with dark matter, possibly connected to ours through extra dimensions, similar to ideas found in string theory and brain cosmology. Another interesting theory suggests the existence of a mirror universe, a cosmos that runs backward in time, perfectly symmetric to our own. Among all these possibilities, one theory that is getting a lot of attention is called conformal cyclic cosmology, or CCC, developed by the famous physicist Sir Roger Penrose. According to CCC, our universe is just one in a long sequence of universes, each one forming from the remains of the previous universe in an endless cycle of cosmic renewal. Penrose even says that there might be tiny traces or leftovers from a past universe hidden in the cosmic microwave background, faint patterns that could hint at events that happened before the Big Bang. Interestingly, the early galaxies discovered by the James Webb Space Telescope may match what theories like CCC predict, supporting the idea that our universe might be far older or far more complex than we once believed. Thank you for watching.